I'm trying to find things that people are interested in learning, so that these Saturday classes, uh, mean something. But I found this diagram, and I was like, it's a Whirlpool diagram. But I didn't have the model number of the dishwasher. So I had the part number of the diagram, which is what I posted on the email. It was this text sheet here, and in the upper left-hand corner of the text sheet, I had this part number. So I was like, okay, well, is there anywhere on this text sheet do they put the model number of this machine? And I couldn't find it. And I'm like, well, what? I think I see that a lot of manufacturers do this. They don't put the model number of the machine on the text sheet. So you have a text sheet. If you don't put the model number down, you don't know what it goes to. But anyways, I went to Service Matters, reversed searched it through some other ways, and came out that it was actually an Ikea brand dishwasher that this diagram was for. And Whirlpool had dishwashers with the same components, just under a different model. And then I tried to find a service manual, and the manual I got really wasn't accurate. So there's a couple of diagrams here that not 100% accurate to this one, but I just wanted to get this all out before I get started. So I wanted to break this dishwasher diagram down, and this probably going to be a 2 or 3 part class where I'm going to go over the schematic, and then in other classes I'm going to go over the rest of this information and how could we use that for troubleshooting, and what does all this mean, because sometimes you guys look at these diagrams and you look at all this information and you just look at one thing, and I used to look at diagrams only like I wanted to just see this. I'd never read any of this other stuff, and over the years of looking at diagrams I realized how important some of this stuff is, and some stuff is just there, So let's get into the actual machine. So the first part of the machine is where power comes in, and that's up in this upper area right here. So let's go to this next thing. Power comes into this dishwasher. Let me just grab some of these meter leads here. Okay, so if we're looking at this dishwasher, in the gray down here, this is the main control board. This is the brain of the whole entire dishwasher. So if the dishwasher did not work at all, we have lines coming in here neutral, and we have line 1 coming in here. Where on this board would we be looking for power if this board did not work at all? So you went into this unit, it was plugged in, you got power at the wall, but your display doesn't work. Nothing, no buttons do anything. You open and close the door, it's latching properly. So you want to make your first test at the control board to see why the board's not lighting up. Where would you test on this board, on these pins here? Now we got 2 door switches, one here and one here, and I got only one showing, but this is the bracket. You can see the openings here on the bracket, that there'd be one switch on either side. I'm going to talk about that, why we have the 2 switches. You have any guess there? I'll make it a little bit bigger.
You're talking about on the schematic, right?
Yeah, on this diagram right here, where is power coming into this control board? If we follow,
you got line 1,
okay,
which is your hot, and you got neutral. That's where your power's coming in at.
Yeah, so if you follow this here, it breaks off into 2 directions. It goes this way through the door switch, and it goes down here. Which way do you think it would go?
Well, you got L1 there. It says the switch mode power supply.
That's correct. And think about this. If you're running a dishwasher through a cycle, and you turned it on and water started filling and it actually started washing, and the customer said, oh crap, I forgot to put this glass in or this something in. If they open the door, and the dishwasher will stop obviously, you put the glass in and close the door, would they have to reprogram it and start back from the beginning, or would it start wherever it stopped?
It should start back where it stopped at.
Okay, well, see, now that's why we broke off into two directions here. This door switch doesn't have anything to do with power coming into the control board, and we don't want that to happen, because if that happened, that could be that the control board would lose whatever program the customer programmed it to. Just like a microwave, you got door switches on a microwave, but if you put 2 minutes on a microwave and you open it up after 1 minute and you close the door, it still says 1 minute. The door switches don't control power to the board. So if that's line 1, what's the other side of the circuit? Got neutral up here, and again, it breaks off into two directions. So that would be right here on P2. That would be P6 and P2 would be the power coming in, and you can see the neutral goes here. Now the neutral also goes down to this circuit and this pilot relay, which I'll get into what's going on here with this. But these are the points that you're going to make the test at the board and see if the board's working or not. The door switches only control the actual components, motors, water valves, heating elements. The door switches don't tell the board that the unit's running or not. So it watches that circuit though. It knows that that circuit's de-energized when you open and close the door. So P6 and P2 are the points on the board. Now if we look over here, I have a picture of the board, and let me bring my meter leads into that diagram too. Good morning, guys. So we were checking power coming into the board for those of you guys that just came in. So we identified on the diagram that P8 and P6 are I'm sorry, not P8, P2 and P6. If you look in the screen before, we were saying neutral came into the board here, and line 1 came into the board here, and it went to something called the switch mode power supply. Okay, now if we look at that, does anybody know where that switch mode power supply generally would be on this board by looking at the board itself? That's these components right here. That right there is the heart of this board. It's your step down transformer. So power comes into this board right here. You see this L1 and neutral. I'll go back to the previous screen that it comes in here, but look how much voltage comes out. Only 5 volts. And that switch mode power supply, if I got 120 here and I got 5 volts there, a transformer is what does that. It's what steps the voltage down or raises it up, but it also has a controller for the circuit, because if you look here, this is L1 and neutral. This is what type of voltage, AC or DC? It's AC volts. But if you look over here, what do we have coming out? Do we have AC or DC coming out?
DC.
Yeah, we have DC coming out, and that plus sign in front of the 5 volts is the indicator. Even though they put N as neutral, that's not neutral. That's the DC circuit. And the DC circuit is separate from the AC circuit coming in. So going back to what we started, is we said that the power supply gets power all the time except for something right here, this non-resettable bimetal. Now I didn't get a chance to look that part up, but I will show you what that looks like in a little bit. So if we look here, this is our power supply that's bringing power in, and we said P2 and P6. Can anybody find those, that P2 and that P6 on the screen? Looking at the board, and I'll even make the board a little bit bigger for you guys because I don't know how much of the screen you can actually see. But where are those points that my meter's on the diagram? Where are they physically on the board?
The P2 is right there above that red.
That's like a capacitor or a varistor.
Yeah.
So that's P2 right there, right? That's line 1.
And then P6 is above there, the third one to the right.
Right there. Yeah. Okay, so that's where your power's coming in. That's this point and this point on the wiring. I'm sorry, this point and this point on the wiring diagram, and I'll highlight it in yellow here and here. So if you went to a customer's house and the dishwasher wasn't working at all, you're like, okay, well, where do I begin? And the first thing we want to know is power getting into the machine? Now, what if I put my meter on the board here and it said I got 0 volts at that point? What would you do? Any ideas? I'll go back to the other diagram here. You're making this test here and your meter says 0 volts. Now we said where there's a power cord that runs underneath the sink, is plugged into a wall. You unplug that and you know you got power there in the wall. But you're at the control board here, so we got power here, but we're at the control board on P2 and P6, so we don't have power.
Yeah, you got that resettable bimetal there.
Yeah, and the power cord coming into the machine would go directly to that part. Now, there's only one other thing. Let's just say you checked that bimetal, and that bimetal was good. You're not going to really see the answer in the diagram, but do you have an idea? If you got power in the outlet on the wall, and you have no power here at the board where my meter is at, and you check the resettable fuse, and it's good, what do you think could be bad? Now, only experienced technicians would see this. So if you haven't worked on 2A dishwashers, you might not ever see it. Well, I'll give you the answer. Have you ever looked at a dishwasher, how power comes in? Where does it go from the wall? It goes right to what? Before it goes to the control board or any parts of the machine, you're installing a dishwasher. You got that little tiny box where the wire nuts are, and the power cord comes in there, and the black and white wire of the machine, you got to connect them. I don't know how many times I've seen where the people installing the dishwasher don't tighten the wire nut, and so the wire nut actually burns, and here you are, like a dishwasher don't work at all, and it's a burnt wire. So before we make this voltage test here, even though you may have it in the wall, always check the connection where the power comes in. It's usually in the bottom right hand side. You got that little junction box in the dishwasher. Hold on one second. Let me see here.
Hey Richard, that's one of the first things I check when I don't have power. Nothing's lighting up.
Yeah, that's exactly what you want to do, because if not, then you're sitting there chasing a ghost. I was trying to find an image of installing a dishwasher while I was doing this, but it's going to take me too long to find it. So we'll just keep moving, and I'll show it in the next video. I'll just step back to it. But so here's where you would check on the board. Now if you got 120 here and your board does not display at all, what would you do? It's probably a bad board. Okay. The only thing is that there's this 15 pin connector here, and let's go back to the diagram just for a second. There's a 15 pin connector on the board, and I think it's this one right here, and that would be your user interface, like the buttons that you would press on the outside of the control. So you want to make sure that's clean and it's connected, and the customer didn't have cockroaches and crap all over this thing and whatever happens here. But these are the display and the touch panel in the front, and you could have a problem with that. Now you say, well, how do you check that? You really can't. Back in the day when electronics came out, manufacturers used to give you a schematic of these touch panels and told you if you press pin 1 and pin 8, you could press the start button and see if it actually made a connection. I haven't seen that in years. So really, most likely if it's not working at all, it's going to be the main board. But you do have to realize that sometimes it could be the user interface or the touch panel. So that's what this connector is on the left hand side here, and it was labeled P1 in the diagram. So let's go on to the next part. I did search, and it's a Whirlpool part number, but I found it under Kenmore, and like I said, this is also for an Ikea dishwasher. This is our power supply here. This little black chip here is the entire program, every wash cycle that the customer has and options that the customers has. It's all programmed and saved on here, just like you have those little thumb drives you plug in a computer. That's the brain. So this is what's telling this board what to do. Now if we look, we have these three boxes here. These are your relays, and we're going to identify them in a minute. We got 3 relays on this board, but then we have something else. It's TR5, TR3, TR4, and I just want you to remember those numbers because we're going to come back to them in the wiring diagram. So this is our user interface coming in here, and then if you look at the very top, that's very nice for Whirlpool to do that, because this is your soil, this is your temp, this is your dispenser, this is your drain, this is the fill, this is the vent. They're showing you right on the board, okay, if you plug in 2 wires here, that's what it's going to. But we also can use a schematic to find those pins and locations. So let's take a look at the diagram here. And I think I was going to get into the power test that I showed you earlier, but I just want to show you that this is the board, and everything here is run off of here. Our power coming in, we've already identified, goes to P2, and it goes to here. And if you look, there's a little L1 there, and there's an I don't know, that's an M. Oh, it just says W, I guess, for white. So that's where power is coming in. So the power is coming in here, and notice these bigger terminals. Whenever you look at a board, you see big terminals like that. That's usually an indicator it's 120 volts or power coming in from the power supply. And then you can see the output are just these little tiny plugs here. So we'll get to them in a minute. So let me see something real quick. Let me move this board. I think there was something here I wanted to show you. So yeah, so if I was to flip this board around like so, it's almost in the configuration of the drawing. If you see that we go back to the user interfaces coming here on the right hand side of the screen, and this is where the user face comes in here. And then if I stretch it out a little bit, like that. It's like it's almost like that. All of these components here at the bottom are all plugging in here, except for a few are plugged in directly here. And we're going to get to that in a minute. But everything else is here. Now notice in this whole diagram, remember I told you the switch mode power supply has a drop down voltage, a low voltage. And if we look over here, here's our low voltage output. I'm going to draw a line here and show you there is a separation of voltages. That everything above this yellow line and to the right of the yellow line, all of this is running off the 5-volt circuit. Okay? Everything on the bottom of this yellow line is a 120 volt circuit. So we have 5 volts DC on the right, and we have 120 on the left. So 5 volts and then DC, and then we have 120 over here. So that's what I wanted to bring. So all these components are here on 120. So now I wanted to get into some of the components, how they connect to the board, and if that particular component's not working, how do we troubleshoot that out? Where do we make the test and everything else? Any questions on this so far? No? Yes? Okay, we'll keep going. Alright, so here's a motor. And I broke it down into parts breakdown by looking at this image right here. Look at the parts list and tell me, what parts am I looking at? Just by looking at the key numbers on the parts breakdown. So one is 18, which is the motor itself. Is 16 there? Anybody see?
Got a impeller?
Well, the impeller is actually right here. That's more of a housing.
Housing.
And if you see this gray piece, that's that housing. You see how there's a half a piece, and right here there's no plastic? And can you see the opening here? Now this piece here would probably be the seals and the impeller. Now I don't know if this unit has a capacitor, but it shows a capacitor here, number 24, and the nut to hold it on, but it's probably on the other side of the motor. Now if you see that, you could order any one of those parts individually, or you could just order number 9, and all of it would come as a complete assembly. So if you order just number 18, realize it's not going to have a capacitor, it's not going to have all the parts of the pump, and it's going to be a lot harder for you to complete that job that fast. You have to take the old pump completely apart and move parts over, and then you got to be careful, like here, that this is the water seals, and if they're not installed correctly, water could leak out. Now some of you guys probably haven't been doing appliances that long, but when I did dishwashers back in 1980, you had to rebuild the pump from the bottom up, and you had to put seals in there. And not only that, we had this little, here's like the shaft of the motor would be here, and this is the bottom of the pump housing, and you had to put this impeller on here. And in order to do it, sometimes you had to put a washer there, and you're like, well, okay, do I have to put a washer or not? And they had this piece of cardboard that was cut like this. I remember exactly how it was. And it's set, the outside piece is set here, and the piece went here. And if it touched the top of the pump, it didn't need a washer. If it had space, you had to put a washer. And underneath that was the seals. And if you didn't put the washer, didn't do it properly, the pump would jam up and wouldn't run, or it would leak water all over the floor. So if I was ever to rebuild a pump, I would just order number 9 and replace this whole assembly. But if you even wanted to do it more, now obviously it costs more, but if you look, all of this comes as a complete assembly if you want, and not just change the motor, and that would be number 12. You order number 12 and you get everything in this rectangular box. So that's the key numbers with the parts. Let's get back to the diagram. So here's our motor. Where on the board would I check to see if the board is telling my motor to run? I go to someone's house, dishwasher fills up with water and just sits there. And after about 3 to 5 minutes, customer hears water pumping out, but the soap's just sitting there at the bottom of the dishwasher. The dishes and plates are filthy, so it didn't actually wash. So where would you check on this schematic for if the motor is working or not, or the board is telling it to work?
That would be pin 5 and pin looks like 9.
That's correct. So pin 5 and pin 9 is where you would put your meter lead. You know, it took me years to figure out how to make those transparent so I could use them on a diagram like that. So what would I check from pin 5 and pin 9? I go to someone's house, dishwasher is, filling water and it's not running. Right there I put my meter, but what am I actually looking for? Voltage. Let's say you have voltage. What other test could we make at that point?
Unplug it and check the winding.
Yes, we can unplug it and check the winding. Realize that there's also a capacitor in that motor, so the capacitor could be at fault. So you have to know, hey, when I'm making a test, yes, I can test the motor from here, but my resistances aren't going to be 100% accurate to the diagram because there are 2 windings. And when you put 2 windings or you put 2 or 3 loads in parallel, the total resistance of that circuit would drop. So if it told you that this winding was 5 ohms, being parallel to another winding, it could read 2 ohms. That's what happens when you put things in parallel. So I see 3 pins on the motor. Do you see 3 places on this motor to test? I only have 2, right here and right here. That's actually on the motor, but I got 3 pins. Do you know what pins you would check?
The 2 silver ones.
The 2 silver. Why the 2 silver ones?
They're alike, so I assume that's for the winding.
Well,
the other one's for the capacitor, maybe.
But you're correct. No, it's not the capacitor. If you look, and I made this zoomed in. Look at that copper pin, and you see it follow all the way up here. That's ground. That piece is ground right there. It's not in the diagram, but it'll probably be a green wire grounding it out. They're not going to have that motor without a ground on it. Okay? So you're right, it's the 2 silver ones, and that's these 2 points on the diagram. Now this diagram isn't 100%. I should have taken it from the tech sheet, but I took it from the service manual, and then when I looked closely at the manual, I realized it wasn't accurate. But if you see here, the run winding's 3 ohms, and the start winding is 6 ohms. So if I was to check between violet and blue for total resistance of the motor, now the capacitor will affect my reading, but what is the total resistance of that motor?
9 point what? 9 point.
No, you are doing series ohms calculations where like one winding was in series with another. You would add them. But good guess. Let's just say, well, how do you figure it out? Let's just round that off to 4 and 6. I'll go up a little here and down a little there, okay? So you take the 2 and it's 4 times 6 divided by 4 plus 6.
Yeah.
So 4 times 6 is what?
24.
Over 10, right?
Mm-hmm.
And then if we dropped it down, it would be 2.4. So my total resistance is only going to be like 2 ohms. Okay? So I want you to realize, you look at the diagram and it says, oh, this is almost 4 and this is almost 6. I'm only getting 2. This motor's bad. And that's not the case, because they're in parallel with each other, and the parallel resistance would always lower the reading. Okay? It still doesn't lower the resistance of this winding or this winding, but it gives electricity 2 paths to go, which lowers the total resistance. I don't want to get into that. That's Ohm's law. But yes, if I was to check this motor for power, I would be right here and right here. So let's take a look at the heating element. All right. So we have a high limit thermostat right here. And let me bring it to the front. We have a high limit thermostat right here, and we have the heater right here. Well, you know what? I can't put it there because it'll overlap my diagram. Where on the board would I check to see the same thing that we did with the motor? You want to make it bigger, guys?
Mm.
Where would you put your meter this time?
I'll let them guys answer. So, there you go.
P9
And P3.
and P3, correct.
Mm-hmm.
So that's on the board, and we'll take a look at the board to see that test. So that is the heating circuit. Now, question. Would anybody have an idea what high temperature wash on a dishwasher is? The highest temperature that a dishwasher should run at?
I think it's about between 150 and 160, right? And maybe lower now.
No, that is correct. And that's sandy wash. What's the benefits of that hot water? Any idea?
Kill bacteria.
Mm-hmm.
Kill bacteria and also help release grease and everything else, because sometimes grease, it solidifies almost like wax, but that extra hot water breaks it down. But like COVID-19, and you got everybody in the house, run your dishwasher on sandy wash, pots and pans or scrubs or whatever, because that'll reduce the contamination of germs from one person to another using forks and glasses and everything else. And this is something you want to recommend to customers when they ask you about cycles and why would you use one over another. So let me ask a question. How is that how is that controlled? How do we control that temperature? Looking at the above circuit.
That's a bimetal, so.
Yeah, but you notice it says thermostat high limit.
Oh yeah, high limit.
Let's go to a dryer. We have thermal cutoffs, and we have high limit switches, and we have thermostats. What's the difference? I didn't hear what you said.
Cutoff is probably like a fuse.
Yes. So this is a fuse. So then how do we control the temperature? This piece right here is this piece, but it's a fuse. Let's go back to the diagram for a second. Let's go back to the main diagram. I don't know if you guys were able to download it, but so what is controlling my temperature? If that thermostat's not controlling my temperature, how is my temperature controlled?
Is there a thermistor somewhere?
Yeah, maybe.
I don't see it.
I'll give you guys a second to find it. Cause see, listen, if you really want to get good with diagram, I could point it out to you and say, "Oh, it's right here." But you guys, this is how you practice and learn diagrams. Is like just take a diagram and pick out one thing and try to figure out how it operates, and using these text sheets. But yeah, there is a thermistor in here. It's actually a different color from all the other parts. Gave you a hint. That's on the right hand side of the diagram. Towards the bottom. It's on the low voltage side of the board. Because a thermistor's not 120 volts, is it? So let's go back to what I said about the power supply. We have a 5 volt circuit and we have a 120 volt circuit. So if you know half of that board is 120 volts and we're talking a thermistor, when would we ever put 120 volts to a thermistor? It's always low voltage on any machine. So just by knowing a thermistor is a low voltage component and would probably tell a board temperature, well, now I've just eliminated this half of the board. This half of the board here.
Oh, I see it.
So this half of the board is irrelevant. Everything on that half of the board is 120. That's going to be my heating element, my water valve, my drain pump, my drive motor, my door latching mechanism if it's motorized, maybe a fan motor or something like that. But if you look now, we've just eliminated and we come down to only these components in our low voltage section, and it says thermistor here as well as it says thermistor here. But you see, if you knew that this was 120, you knew this was 5 volts, and then you know you're okay. So if this is not controlling my thermostat, maybe a thermistor, because that's how boards know temperature. Okay, well, I got to go to the low voltage side of the board. Okay, so
I have a question.
Sure.
Yeah, so I mean, working with Whirlpool, I've seen the thermal cutoff, I've seen the optical sensor, but I've never seen the thermistor physically. You know, so I expect it to be like embedded in the water or something.
I have that. That's the next slide.
Oh, okay.
I'm ready for you. I spend a good 2.5 hours every day when I do a class like this. I get up early in the morning, have my coffee, and I go and I look at the diagram and say, what am I going to talk about? Let me get pictures. Let me get images. Let me, what's going to come up next? And it takes time to put this stuff together so that I have a meaningful content. So going to it, let's go to, we'll get to this right here. That's what you were talking about. But let's go back to, we said here P3 and P9, right, is where power comes in. So just for the heck of it, let's just find out where are we going to test on the board for that. I'll zoom in on the board a little bit. P3 and P9. So remember, all this up here, guys, a majority of this stuff is low voltage, okay? So where are we going to put our meter leads? P9 and P3.
Behind the relays.
Yeah, it's right there. So here's P3 and P9 is right there. And that's where you're going to check from the board to see if power is going to the heating element. And we could also do what? Ohm it out, right? So if it's open, we don't know whether it's the high limit or the heating element. So you have two options. Either you just order both when you come back and you get down underneath the machine to test directly. But it would be sad that if you go and you check P9 and P3 and you got 120, you check continuity, you got no reading, you say, well, ma'am, it's either the heater or the thermostat. I'm just going to order both and I'll come back and fix it. And then you come back and you open the panel and see one of the wires burnt off. It's like you could have fixed it the first time. Now you ordered parts, you got to return those parts, and you went back to the customer's house a second time for something you could have fixed while you were there and got that money right there. So again, you don't have continuity from the board. It's always good to spend an extra couple minutes going down to that component and confirming the part that has failed. Y'all know Miss Ward, right?
Mm-hmm.
She called me the other day on a microwave that's working intermittently. So she likes to order parts and have parts available, so when she goes out to do a job that she has it to complete right then and there. But she was like, well, what could it be? And I says, well, if it works intermittently, maybe the magnetron's getting too hot and causing the magnetron safety to short cycle, or maybe door switches. I've seen door switches melt, sometimes work, sometimes not work. And she said, no, the door switches all been updated on this thing, and the thermostat is not bad, and the magnetron's not getting that hot. And she found a wire burned on the thermostat somewhere else in the machine. I don't know if you know the space savers. You pull the control panel, there's two little thermostats there, and one's normally open for the exhaust fan and the other one's normally closed. And that one is like when someone's cooking on the right front burner, but the wire was burnt. So like I said, you could check for ohms, but if you don't confirm that the part's bad, you could have completed that call. Just imagine you drove 30 minutes to a customer's house and you order a part and come back and find it was a burnt wire and you had to drive back again. So take that extra time to check those components. Let's go into thermistor now. So we actually have two different options here. So this diagram's a little, little bit hard to follow through. I'm gonna be honest with you, I don't know which pin on here is the thermistor. Okay, this is NTC input, so that is the thermistor input. Now what? How do you check that thermistor looking at this diagram? Is it pin 15, 2, 3, 4, 5, 6? There's nothing else there written there saying it. Now,
I don't think you can check, because I think it's built into the.
But
now I know. I think it's built into that OWI sensor.
It is built into it, but you could check it because they're telling you this is the NTC input. And if you look, the thermistor here is an NTC, which means when the temperature goes up, the resistance goes down, negative. That first word, negative. But let's go back to the full diagram for a second. So let's say I'm trying to break down a little part of it and then have you go back to what am I looking at, right? So if we're looking at this diagram here, we have a positive and negative wire coming off this, and I'm going to move this around here and expand it just a little bit more for you. I'm trying to keep everything on the screen here. Okay, so if this is NTC input, what do you think that means by NTC input?
It means reference voltage to the, or rather, a reading or a signal supply to the board. From
Okay,
NTC.
so is voltage going down this way or is voltage going up this way, and how do I know?
It says input, therefore it's going into the board.
Down or up? Down or up though? Say which arrow?
Up.
Okay, you are correct. So if that's going into the board, what do I need to go into the sensor and then back out the sensor into the board? I need my positive, my 5-volt positive, okay? So that one coming here goes down into my thermistor and my turbidity sensor here, and this one's coming out. So if you did pin 3 and pin 1, you would be checking your soil sensor, your thermistor. But that is what is sensing the water temperature. Go to that part there. That right here has an optical sensor, but it also has a built-in thermistor sensing the temperature. Do you know how the turbidity sensor works?
Yeah, it uses either laser or infrared to sense how cloudy the water is.
Exactly. So you would have 2 beams here, and it's usually infrared, and it's the same thing like when you go to a clothing store, and as you walk in the mall and you go into the store, it beeps letting the worker know you're there. They break the light pattern here for a second, and that's what causes it to beep. Well, they're using the same thing here, that this is down in the sump where the pump assembly is, and it's designed to be in the water flow of the dishwasher as it's washing. But when you first turn the dishwasher on, the water's super, super dirty, so it's causing this beam of light to flicker on and off many times. So what does a dishwasher do with that turbidity sensor? Okay, so the turbidity sensor, as water flows in between those 2 beams here, it's going to cause that to flicker, and that pattern's going to come back to the board here. But what does it do here? And that's going to be which pin coming off this board as well. So we're going to use the positive voltage coming in, which was 15.3. Which one is the one coming out? Just so we know how it works.
It's the optical signal.
The optical signal. So this is the one coming out of that optical sensor. But what does the dishwasher do with that information? It's coming on and off. Okay, the water's dirty. What do you want me to do? Throw more water in there?
It's going to prolong the wash cycle. It's going to make it add time to the wash cycle.
Yeah, but not really add time, because the water's still going to be as dirty as it is. How do you get rid of the dirt?
Drain and fill and start over.
Exactly. So in other words, most dishwashers, especially mechanical timer, it'll fill 6 times, it'll wash 6 times, it'll wash 2 or 3 times, and all the others are just rinses. Okay, so what this thing will do is it'll wash with the soap, and the soap's going to show that it's dirty too. But just like washing a car, after we got soap, we dumped the soap out. Now we're washing with fresh water. So now the turbidity sensor is washing the fresh water to see how much dirt and debris is in there. And if it's too dirty, well, if you're washing your car and your bucket, you just got finished washing the rims of your car and the bucket water's nasty, are you going to take that rag and put it now on your car and start washing your car? No, you're going to dump it out, rinse it out, put fresh soap and water so that you're not washing the rest of your car with that dirty water. Well, that's what's going to happen here. It's going to fill up, it's going to wash its normal wash time, but it's not going to be 6 fills, 6 washes, 2 rinses, or whatever a mechanical timer would do. It would take and dump it out, and it fills up for rinse, and if the rinse is too dirty, we're going to dump it out, fill it up, and rinse again, and we're going to try it 1 or 2 times depending on the manufacturer. And if that don't get it that clean, well, we're going to throw a separate wash cycle in, and that's why you got 2 compartments for your detergent. And it'll dump the soap another time, and it'll keep rinsing until it gets the water as clean as it possibly does. So that assures the customer, hey, this dishwasher did everything it possibly could and even test the water to get that thing clean. So that's what the turbidity sensor does. it extends the rinses or causes more rinse cycles to try to get as much dirt out as possible. So that goes into our detergent dispenser here. Is a detergent dispenser 120 or low voltage? I don't think I had the whole diagram here, but
I think it's DC.
Low voltage.
Well, we got this.
Okay.
Remember, this is our division between our low voltage and our high voltage here.
Mm-hmm.
Okay?
I
So,
couldn't see the whole schematic. That's why I said.
no
I
problem.
see it. I see it now.
Okay,
120.
well, I wanted to go over, there's still a couple more things we got to cover, so I'm going to go a few minutes over this 1 hour class. But so our dispenser is 120.
Mm.
How many times does our dispenser here dispense?
Once.
Once. Okay, but what is inside of this compartment?
Oh, okay. So it'll dispense the soap, but it'll also dispense the rinse aid.
Alright, so we have two soap containers. Let's start off with the soap containers. How do they work? Customer says, which one do I fill and why? So it says pre-wash here. This is the main wash. So if the customer's using a light load, let's just say it's an older couple and they only have like about 4 or 5 plates and glasses for the whole week, and they use paper plastic products for eating and drinking, well, we're only going to fill out this one compartment. And if you see, it's got a seal around it so that it's designed to dispense that detergent halfway through the cycle. So if they don't put detergent in here, it's mainly just rinsing with water, draining out, rinsing with water, and then it drops the soap. But in this one here, if you see there's holes in the cover, that allows water to get in, and immediately whatever cycle that customer chooses, that very first time it's going to fill with water, that water will infiltrate this area and dissolve the soap into that compartment. So this one, the door does not need to open to dispense that detergent. This one dispenses it. But if we look at the back of our dispenser, I have this solenoid here. I only have one solenoid. So that'll open up the door, and you can see the little latch assembly here, which is what this plunger pulls on. But then how do I dispense the rinse aid? Because I dispense a detergent for washing. I dispense the rinse aid when I'm rinsing, not in the same cycle with detergent. So what's the dishwasher doing? I'm looking at the diagram. There's only one dispenser there. This thing says spares for future use. It's not even in the machine. This is a wax motor, but it's only used on some models. The wax motor and dispenser motor is either or. It's usually not both. Here's your drain pump. Here's your water valve coming in. This is your air vent, letting the moisture out at the end of the cycle so it helps speed drying. Your heating element and your motor. Well, we only have one component and one part dispensing, but how do we get the rinse aid out? It's the same solenoid. The same part that dispenses detergent dispenses the rinse aid also, but the mechanical system in here is really sort of unique, that when you close this and we energize this one time, just like one time, it just pulls it back. As it pulls back, it just pulls this thing back, and then this lifts up, and then a spring causes the door to flip open. Then in the rinse cycle, once this thing does that first movement, it moves a mechanical piece from like position 1 to position 2, I'll say. And then we energize the same solenoid a second time, And now that this went back to here, to this position without the latch in there, it dispenses the rinse aid. So the same solenoid that opens the detergent also dispenses the rinse aid. And that's also with some of those that have the wax motor, the little rectangular wax motor that moves back, and then it cools down and resets, and then it pulls back again and drops the rinse aid. I do have a video, I think, where I demonstrate it and I explain it to you guys. So yeah, it's 120 volts. You can probably see the two terminals right here. There's one right there and one right there on the solenoid, and that would be here pin 3 and pin 1, or we could check it here from the board. So I think we just ran across the hour, guys. I'm not finished with this diagram. I'm going to cover other parts of it in other classes. I don't like to spend more than an hour training or an hour and 15 minutes because sometimes it's just too much in one sitting. But if you guys got any questions or anything you would like to add or anything?
No.
Appreciate it, Rick.
All right, guys. So like I said, I'll upload this in the members section this weekend and put out an email when it's up. But I'm going to put a little dishwasher series together, and this Christmas time I'm going to add to my sealed system learning thing. I've been writing chapters for the actual refrigerator part of it. It's just been a lot of work, but it'll be uploaded hopefully around the Christmas time as well. You guys take it easy, and I'll see you in 2 weeks.
All right, thank you.
Bye-bye.
Hey, Rick.
Yes, sir.
Does y'all ever have any training like on gas stoves?
Does what?
Gas ranges.
Yeah, I have. You talking about like at our school or videos?
Just in general.
I have some videos on the gas stove. A couple of good ones. One, I have the surface and I have gas. And I'm showing how to measure gas pressure to see if the regulator at the house or the tank is good. I talk about the ignition of it. And then there's another video where let me just stop the recording here.